What is up, everybody? I hope you're having a good day because today is going to be a fantastic day. Today we are going to do sorting algorithms. So what is a sorting algorithm? A sorting algorithm is an algorithm that sorts. I'm kidding. So a sorting algorithm is an algorithm that maybe you have an array of unsorted numbers. You can use the sorting algorithm to sort those numbers. So the only algorithm that I fully understand and I fully know is selection and bubble sort. So I'm just gonna explain them first, then I'm going to tackle the ones that I don't know. There's insertion, merge, quick is the hardest because you have to do recursion, but selection and bubble, they're the easiest. I know this by heart. So first of all, let me explain selection sort. What selection sort is, you have an index, which is the first index 0. So then you keep that, you hold that index 0, and then you go to your array, you transverse through array, and then you come out from that array with the smallest element, the first smallest element, and then you put it in the first index, and then you go again in the array, you look for the second smallest element, and then you put it in the second index, third smallest element, and then this is just sorting. And here, this if statement here is going into the array and looking for the smallest element, finds that small element, keep it, and then it's going to put in its respective index. And then there is bubble sort. Basically what bubble sort does, it goes through an array, and each time bubble sort transverses, it makes sure that the largest element is in the last position. That's why we have j less than n minus I minus 1, because every time bubble sort transverses, it makes sure that the largest is at the last, so we don't have to go back on this. We don't have to reach the last element on the second iteration. So yeah, it will make sure that the biggest ones are like being sorted in at the back and then up to the first one. So what it does is that given an array, we have to create a bool swapped, and we have to initialize, we have to give it a value of false, and then we have to iterate, as I've explained why we have to do this. Here you have to do -1, or you can just leave it at n, but if you leave it at n, at -1, at n minus 1, the array will already be sorted. So that's why we just do this. That one extra space is very, very necessary. So you do that. Then if array j is greater than array j plus 1, so array j will be 0, so it will be the 0 index. The first element is greater than the second element, then we sort them and then go to the second element and the third element. If the second element is greater than the third element, then we sort those, and then the third. Okay, maybe I just need to write this down. Let's go. I know bubble by heart, guys. Don't worry about it. But bubble is very, very easy, very, very good algorithm. I learned it in Java. I think it was last year. Beautiful Java. Now we're doing C++. We don't write garbage anymore. Okay, I'm kidding. To all the Java guys all out there who love Java, I'm kidding. Java is not garbage, guys. It's a good programming language. Okay, so let's say we have an array. I like to use 6 2 3 when doing these things. I don't know why. Even when I was doing Java last year, I used to like do 6 2 3. Those are the three element array. I just use that. Okay, so bubble will start here and check if 6 is greater than 2. Then we'll swap 6 and 2, and then we have 3 there. We have 3 there at the last, because we won't reach there. And then we go to here to 6, and then 6, if it's greater than 3, we swap again. So at the end, the array will be, oh shit, this is 3. Yeah, this is 3, guys. Shit, my bad. Let me just boom. Okay, yeah, this is 3. Let's write everything clear, because 6 is greater than 3. And then when it goes again, that boolean will be false, because it will not have swapped, because if it goes again, it won't swap. And then if it's false and we do this, it will turn into true, and then we'll just break. That means that our array is sorted.